what we want to graph. Since you don't have to copy it again, I do. So e to the x, less than or equal to 0, x minus 1, and natural log x, x greater than or equal to 1. So one thing that I would like us to look at before we continue is the fact that this function, e to the x, increasing on all its domain, or this function, a to the x, decreasing on all its domain, has domain all real numbers. I like to call these functions friendly. I don't have to worry about them. Well, what can you say about the domain of natural log?
Infinity.
Let's look at the graph and identify the domain of natural log. Maybe I wasn't clear.
So your domain would be non-inclusives of 0 to x, or to infinity.
Excellent. Of course, this is a vertical asymptote. Why? Because this is a horizontal asymptote in the original function. Its inverse will have a vertical asymptote. So the domain of natural log is 0 to infinity. So I call natural log not friendly. So as you see it here, also from 0 to infinity. So the domain of any log function is 0 to infinity. Any log, I want to say base function. What am I talking about? Well, if I am asking what is the domain of x, natural log of x plus 1, it's not 0 to infinity. Because this is not a pure base function. It's not the simplest. So I have to write that x plus 1 is greater than 0, which makes the domain from -1 to infinity. So this statement is valid only for a base function. No transformations. This is a transformation. This is a shift to the left of 1 unit of this function. So this one will have and has the vertical asymptote at 0, but this one will have the vertical asymptote at -1. Totally different story. So what I'm saying is, in general, log is defined only on positive numbers, not even 0. Okay. This one is friendly. This one we have to be careful with. So remember what we have to do first. We have to identify the domain of this function. And in the process, because it's a piecewise defined function, we will change this into an interval, we will change this into an interval, and we will change this into an interval. Can anyone give me those intervals? This should not be a problem. This should come in just quickly.
So you want, or I'll go e to the x.
Perfect.
So your interval will be -infinity
Very
to inclusive of 0.
excellent. That's all I needed. Perfect. The second one, anyone?
Not including 0 and not including 1.
Good. And the last one, anyone else? Anyone? Everyone has to say something.
Including 1 to positive infinity, not
Good, excellent. So now can anyone identify or establish the domain for this function?
It would be -infinity to infinity.
Good. So I saw it in your work that you established the domain correctly, but you did not write -infinity to infinity. This is the domain. Please do not omit the endpoints. If that's what the domain is, that's what I need to see on the table. Not just -5 to +10. No. This is the domain. And that is what we have to write. So, and this is f of x. Good. So which are the most important, I shouldn't say the most important, which are the values that I have to put in the table right away? Maybe I should say that better.
0 and 1.
Of course. Why? Because here something happens, something crucial happens at 0, and of course something crucial happens at 1. So no doubt that these numbers have to be in the table. Accordingly, I have a bracket to the left, a parenthesis to the right. They have to touch one another, and they have to be exactly under 0. At 1, the same thing, but reverse. Parenthesis to the left, a bracket to the right. They have to touch each other, and because when we leave a space, it's a different situation. That's why I'm specifying they have to touch one another. Parenthesis and the bracket. There is a possibility that we have this and we had that. It's a different story, right? So this means that the point is whatever, comma 3, and the limits left and right are totally different. So in this case, 0, 0, 1, 1, they have to touch one another. There is no space in between. Good. What is the function that we have to work with in the first branch, second branch, third branch? Why am I writing this? Because sometimes these may not be given from left to right. And I have to identify them and not evaluate the function for something else that I shouldn't be evaluating it for. Ready?
E of x
E to the x, very good.
and x minus 1.
Very good. And obviously natural log x according to this. Awesome. In e to the x, I can plug in anything I want. So I'm going to plug in -1. -1, e to -1 is 1 over e. It's a tiny number. Difficult to plot as an ordered pair, but I'll do my best. When I plug in 0, what do I get here?
1.
Very good. Yes. So any number raised to 0 is 1. So any number raised to 0 is 1 except 0. So please remember that. 0 raised to 0, it's a very important situation. We're going to talk about all of them. There's 7. It's called not undefined, indeterminate case. And they are a total of 7. 7 indeterminate cases. This is one of them. When we have 5 divided by 0, we call this undefined. So please, I'm boxing all these things in for you to review, please. Okay. 0 on this side, obviously I get -1. 1 on this side, I get 0. 1 on this side, natural log 1. Do we remember how much is natural log 1? Yes, I know we can plug in the graphing calculator, but I don't want to do that. So let's say I don't know what this is. So this is equivalent to, this is very important, natural log is very important. We're going to use it in logarithmic differentiation. It's very important. What is the base here? I don't see any base. We normally write log base a of x, and that's the base. But what is the base here? I don't see any base.
10.
Careful. Very good. Thank you for telling me that. This, where I don't have a base, this is base 10. When it's ln, it's base e. Very easy to remember. Where's my calculator? Here it is. See, they are together, e to the x with natural log. Why do you think that e to the x and natural log are on the same key?
They're inverses.
Of each other. Awesome. What do you think? Why do you think 10 to x and log log are on the same key?
Again, because we're inverse.
Exactly. They have to have the same base. They will not be inverses if they didn't have the same base. Okay. So E, maybe I should explain this conversion before I come back to that. Let me explain. This is the most important part, concept from log and exponentials. Any log equation can be replaced by an exponential equation, comma, and vice versa. Any exponential equation can be replaced by a log. And that's why we are going to use this double equivalency. We're going to use this double equivalency in this chapter for the formal definition of the limit. Double equivalency. What does this mean? It means that this concept implies this concept implies this concept. Okay, so let's write the concept now. Okay. Log base A of x is y. We always start with the base and we go counterclockwise. Base, counterclockwise. The base raised to power y equals x. The most important concept in logs and exponentials. And now I can address this, what I'm getting at. So log in any base of x is y, a raised to y equals x. So now here, e raised to which number is 1? E raised to this number is 1. What could that be?
0.
Only 0. So that's why we get 0 here. So natural log of 1 in any base is 0. I meant to say natural log, I'm sorry, log in any base of 1 is 0. If it's natural log or if it's log base 10 or 5 or 3 or 1/2, it doesn't matter. Log applied to 1 is always 0. How come? It's this point here. Log applied to 1 is 0. Is this point here. Log, natural log applied to 1 is 0. Okay, enough of that. What am I trying to do? Okay, here. So let's also plug in, let's say, E. How do I know that E is there? Very simple. Go to the graphing calculator. Maybe I should show, let me show with my app, because it's easier for you to see, I think. I'm going to share my screen. Here it is. Here it is. It's coming. Wake up, wake up, wake up. Okay, so this is what I did with my stats class today. Okay, so if you don't remember what E is equal to, or you want several digits of E, second and the division symbol, here it is E with no power whatsoever, and just press enter. And it gives you 2, 4, 6, 8, 9 digits of E. So obviously E is to the right of 1. So why did I choose E? Why did I choose E? Okay, let's see why I chose E. So let's take a look.
Wouldn't they cancel out since they're inverses?
You're on the right track. So we want to determine natural log E. Well, I have no clue, but what I know, according to this concept, what is the base here? I don't see it. Again, what is the base?
E.
Very good. So E counterclockwise, E to this power equals E. Can anyone tell us what could that power be?
1.
1. So then I know that this is 1. So here's another property of the logs. Log base A of itself. 5, 5, 1/2, 1/2. E, 10, 10. What is the answer? That's it. So please remember, these are very important concepts. Okay, I have enough. Now, coming back to our table, the question is only asking us to graph and then ask some, no, I don't think so. No, it's asking us something else. I didn't read the whole, but here's my question. By simply looking at this table, If I ask you what is the limit from the left of 1, what will you say? The limit of this function from the left of 1.
I would say 0.
Right here, of course. That's exactly where you look. Excellent. As x approaches 1 from the left, the function values approach 0. What is the limit from the right of 0?
0 minus 1.
That's it. As x approaches 0, I don't even have the graph. This table has all the answers for me. So as x approaches 0 from the right, the function values approach -1. What is the limit from either side of 0? Stop me if you don't see this or if you have questions, right?
D and E.
Awesome, because the left is 1 and the right is -1. Great job. Thank you, Caitlin. Now, the limit from either side of 1.
Zero.
Yes, because both sides are 0. Excellent. So if I ask now, look at the table and tell me, is there a value or are there values for which the limit from either side does not exist? And how many?
There's just one at 0.
That's it. The limit from either side will exist everywhere else. Awesome. Okay, now we're ready to graph it. We already have the answers. We don't need to graph, or we need to graph because this is step 1 with the domain. Step 2, I presented all the table, the table of all ordered pairs that I'm going to use to graph. Step 3 is the graph, and step 4 is the range. Ready? So what do I do here? I'm going to do this because I wrote a lot in between. That's all I need. I only need my table. Nothing else matters. Allow me to